classes. Let us now solve sum number 3 of exercise 8.2. What is given? Quadrilateral ABCD is a rectangle. As soon as you get it is a rectangle, we know a rectangle is a parallelogram in which all angles are 90 degree. So you have this angle is 90 degree, this angle is 90 degree, this angle is 90 degree, and this angle is also 90 degree. Okay. So now, what will be the first? What we have to prove? We have to prove that quadrilateral PQRS is a rhombus. So now, what is the step to prove it is a rhombus? What was the step we remember? To prove that a quadrilateral is a rhombus, first you prove it is a parallelogram. Then you prove adjacent sides of a parallelogram are equal. If adjacent sides of a parallelogram are equal, then it becomes a rhombus. So what will be our steps now? We will have to prove PQRS is a parallelogram, and then we will prove PS is equal to SR. If PS is equal to SR, that means adjacent sides of a parallelogram are equal, so it becomes a rhombus. Easy? Now what will be the first step again? First step remains the same. How you will prove PQRS is a parallelogram? Same method as we did in sum 1, as we did in sum 2. We will join the diagonal BD. In triangle ABD, we have P and S are the midpoints of AB and AD respectively. Therefore, PS is parallel to BD and PS is half of BD. Similarly, you can prove in triangle CBD, QR is parallel to BD and QR is half of BD. Understood? So, therefore, we get PS is parallel to QR and PS is congruent to QR. Opposite sides are parallel. Opposite sides of quadrilateral PQRS are parallel and equal, so it becomes a parallelogram. So this is what we have done in sum number 1. Same we have done in sum number 2. So we have reached up till this is okay. Now you have to prove this side is equal to this side. How we will go ahead? It is given ABCD is a rectangle and midpoints are there. So can I take AB equal to 2A? Whenever midpoints are there, midpoint sums are there now, always take the whole length of 2 times of something. So this is 2A, automatically this is also 2A, opposite sides of a rectangle. And if this is 2B, then this is also 2B, opposite sides of a rectangle. We have reached our first step. First step is over. And we have proved that this parallelogram, this quadrilateral is a parallelogram. So step 1 is over. You have to reach rhombus, first you will reach parallelogram. I have reached my parallelogram. Now only thing is I have to prove adjacent sides are equal, right? So now if this is 2A and P is the midpoint, then this is A and this is A. So similarly this is A and this is A. And if AD is the and AD and BC are there, if this is 2B and this is 2B, then this is B and this is B. Now consider these two triangles. Triangle PAS and triangle RDS. Consider these two triangles, okay? PAS and RDS. Can I say PA is equal to RD is equal to A? Can I say angle A is equal to angle D is equal to 90 degree? Can I say AS is equal to DS is equal to B? Therefore, both the triangles become congruent by SAS test of congruence. Therefore, we can say RS is congruent to PS CPCT. Now, in this parallelogram, PQRS, adjacent side PS and SR are equal. So, it becomes a rhombus. Okay, I just explain you the steps over here. It is given quadrilateral ABCD is a rectangle. So, AB is equal to DC is equal to 2A and AD is equal to BC is equal to 2B. PQRS are the midpoints of AB, BC, CD and DA respectively. So, AP is equal to PB is equal to A. DR is equal to RC is equal to A. AS is equal to SD is equal to B and BQ is equal to QC is equal to B. First step to prove PQRS is a rhombus. Prove PQRS is a parallelogram. Step 1. What you will do? Join BD. In triangle ABD, P and S are the midpoints. P and S are the midpoints of AB and AD respectively. Therefore, PS is parallel to BD and PS is half of BD. Similarly, in triangle BCD, QR is parallel to BD and QR is half of BD. Therefore, PS is parallel to QR and PS is congruent to QR. Now in quadrilateral PQRS, opposite sides, one pair of opposite side is parallel as well as equal. PS is equal to QR and PS is parallel to QR. Therefore, PQRS becomes a parallelogram. Now, parallelogram it is proved. We have to prove it is a rhombus. So these two sides we have to prove. Now, which are the triangles which contain these two sides? PAS and ARDS. So in triangle PAS and RDS, PA is congruent to RD is equal to A from 1. Angle PAS is congruent to angle RDS equal to 90 degree and AS is congruent to DR from 1. So therefore both the triangles are congruent by SAS test of congruence. Therefore PS is congruent to RS, CPCT. Now in parallelogram PQRS, adjacent side PS and SR are equal, so it becomes a rhombus.